Hello fellow problem solvers. So today we're going to be doing a problem that was on my Junior Math Olympiad team selection test back in 2012, problem number 2. I suggest you try this problem out for a minimum of 20 minutes or 10 minutes at minimum. Ideally, half an hour to an hour depending on your level. If you're a junior level math competitor, definitely try it out for an hour, but at most 2.5 hours. Not more than that. If you'd like to go along with us, give it a go for the next 5 to 10 minutes. Just read the problem through. So, now without further ado, let's begin. I got 2 points on this problem, and I think I got the 2 points because I had one part done. 2 points out of 10. So, we have this 4-digit number, and at every point we can either do one of two operations. If we have a number, say, 5502, we can then say increase these two digits, or these two digits by 1, so we can get to 6602, or we can get to 5612, or we can get to 5513. And the other thing is we can decrease digits by 1, pick 2 neighboring digits and decrease them both by 1. And the question is, can we get from 12220, so can we get from this number to 2012 and to 2021? So the first sort of thing to do in these problems is, play around, see whether you can get, say, 2012. So let's try 2012. I want to increase both of these by 1, and I'll get 2320. Now I need to get this down so I can get 2012. So I'm going to decrease it. I'll have 2210. I want to get this up to a 2. I'm going to need to decrease this again though, and I get 211210. If I decrease these 2 digits, now I need to increase these 2, and I'll get to 2111. I'll need to increase these 2 again to get here to a 2, and then I'll get to 2122. Now I have to decrease these 2, and I get to 2012, which is 2012. In other words, we can get from here to 2012. And that's where I got my 2 points, having done this. Now, the question is, what about 2021? And you can try and try and try, but you will not be able to get to 2021. The reason I got 2 out of 10 points, I actually thought I aced this exam, but I did not know how to write proofs. It was because I thought, oh, I solved it. I forgot how I solved it. Mind you, this was a long time ago. So the idea here is you want to see, you can try to get 2021, and no matter what you do, you're so stuck. If you get to 2012, and to get to 2021, you must sort of exchange these 2 digits, but it's impossible for you to do so, right? You need to get this to maybe there's an argument to be made that if you can get to 2021, it doesn't matter the order of operations in which you do. What matters is to get to 2021, you will need to be at 2001. And now you cannot touch this digit, you cannot touch this digit really, and you must only work with these digits. And you can't get to 2021 by doing that. But that's a very iffy argument, not necessarily it matters sort of that we can't go down here. You're saying these will always be the same, but really you're not being very precise. And what you want is precision, a actual proof, there's no doubt about it. This is a bit iffy. So now what we do here is there's a principle that we use, which is when there is a transformation happening. And we're making moves here, so we're transforming this number into a new number, We need to look at what stays the same. And here I invite you to pause for 5 minutes and ask yourself sort of what stays the same, no matter which 2 neighboring digits you choose. And add or decrease by 1. And the answer is, what stays the same is I either choose this number and this number, and I increase them both by 1. And so the difference between these two remains. Now the difference between these two changes, but how do I put this? If the numbers are A, B, C, D, right, numbers A, B, C, D, I can either get to A plus 1, B plus 1, C, D, A, B, C plus 1, D, or A, B, C plus 1, actually, A, B plus 1, C plus 1, D, and A, B, C plus 1, D plus 1. What is sort of the same with these A, B, C, D and every one of these numbers? And the answer is the thing that really remains the same is the sum of these two minus the sum of these two. So A plus C minus B minus D remains the same. In other words, the remainder when divided by 11 remains the same. And you would get this also motivation by asking yourself, okay, what does this remind me of? It reminds me of the divisibility rule by 11. These things aren't changing. If I take another number that's divisible by 11, then no matter what I do to it, it will remain the same modulo 11. It will still be divisible by 11. But this thing doesn't change. And if you see like here, the difference between A minus B doesn't change, and these two doesn't change. Here, the difference between C and B remains the same. Here, the difference between C and D remains the same. And the other two remain the same. So this is the thing that doesn't change. At the beginning, this sum is equal to what? It's equal to 1 plus 2 minus 2, which is equal to 1. But here, the sum is equal to 2 plus 2 minus 1 is equal to 3. Because the sum always remains the same, it will never be a 3. Right? Now, I want to also just like say something like about this contest. This was my first team selection test, and I just failed. My expectations were that I succeeded, that I aced the exam. That was very far from the truth. And what I want to say here is that, this solution doesn't look super impressive. Maybe this idea might look super impressive if you're seeing it for the first time. And the thing is, like, it's okay that it's going to take time. If you're new to proofwriting, it's going to take time to get better. We all start from somewhere. I started from a place where I completely flopped this. Like, I flopped this competition. I went home, I cried a little bit because I flopped. Because I was like, oh, I'm successful. And then I saw, no, I just completely flopped everything. And it took time, and then I got my bronze medals at the IMO later, right? So this is not like your place, sort of your level of expertise right now, your level of knowledge, how good you are, is not something that's static. And especially learning how to write proofs is something that can very much change. This finishes up this problem. And as always, thanks for problem solving.